One correct AI agent answer doesn't mean it's reliable. If you're about to put AI into a daily workflow, this episode gives you a 3-layer stability checklist for deciding whether it can keep running or needs a human takeover. In July 2026, AWS published a production evaluation case showing how the UK car marketplace Motorway tested a dealer stock search agent. The case reduced incorrect results from roughly 1 in 8 to 1 in 50. The key was not picking one good answer, but gating tools, reasoning, and outputs, then retesting consecutive runs and real failures. This video is packed with practical, high-value insights to help you get better at using AI. It's a longer one, so follow Tiny Agent and save it so you don't lose it. First, let's remove the single-run illusion so you know why one clean demo is not enough to authorize ongoing execution. An agent's path can change with tool selection, parameters, context drift, and generation randomness, even when the task looks identical. One correct answer proves that run worked. It does not prove the same conditions will keep producing correct work. If each trial succeeds 75% of the time, the chance of 3 consecutive successes is only about 42%. That is the difference between pass at k, which asks whether any trial succeeds, and pass to the power of k, which asks whether every consecutive trial succeeds. Daily automation needs the second measure because billing, publishing, customer replies, and data changes cannot depend on occasionally getting lucky. The human's first job is to define how many consecutive passes are required, which failures stop the run, and what evidence counts as a pass. Chapter recap. First, one correct answer proves only one run. Second, reliability means consecutive success, not eventually succeeding after enough retries. Third, a human defines the streak threshold and stop conditions before automation. Now split reliability into 3 layers so you can tell whether a failure belongs to tools, reasoning, or the final result. Layer 1 is tool use, selecting the right tool, supplying complete parameters, following a valid sequence, and staying inside permissions. The case targeted more than 95% tool accuracy because a polished answer cannot repair the wrong action trace. Layer 2 is reasoning quality. Claims need evidence, decisions need internal consistency, and missing information must be acknowledged. The case targeted more than 85% for reasoning, allowing uncertainty in complex work without hiding broken logic. Layer 3 is output quality. The result must be accurate, complete, correctly formatted, and useful under the business acceptance test. The case targeted more than 90% for output quality, and all 3 layers had to pass. A fluent final sentence could not cancel a bad tool trajectory. Chapter recap. First, the tool layer checks actions and parameters. Second, the reasoning layer checks evidence, consistency, and uncertainty. Third, the output layer checks the business result, and all 3 layers matter. Next, match a grader to each layer so one evaluator is not forced to act as judge, witness, and safety owner at the same time. Tool names, parameters, call counts, and trajectory order fit deterministic checks because the rules are explicit and repeatable. Complex reasoning, relevance, and semantic completeness can use a separate model judge, but only after you define a rubric and examples. A model judge is not ground truth. It can reward fluent wording and still miss an edge case risk. Humans calibrate the rubric with samples and boundary cases, especially refusals, safety, privacy, and irreversible actions. When graders disagree, inspect the raw trajectory and source evidence before comparing aggregate scores. Turn each grader mistake into a new test case so the suite grows with real work instead of staying frozen. Chapter recap. First, use deterministic checks for structured traces. Second, use model judges for semantic quality only with an explicit rubric. Third, humans calibrate edge cases and take over high-risk decisions. Now build 5 release gates so you know which environment should expose which failure under which supervision. Gate 1 is build time. Use a small representative set covering happy paths, edge inputs, and refusal conditions. Gate 2 is staging. Run the full regression set in production-like configuration and catch drift in tools, permissions, and data formats. Gate 3 is shadow mode. Process copies of real traffic without exposing actions to users. The case recommends observing for at least 4 hours. Gate 4 is a limited A/B test. Release only a small share while comparing the old and new workflows for deviations. Gate 5 is production monitoring. Track all 3 layers, failure types, and human takeover rates instead of watching one average success score. If any gate misses its threshold, return to the previous layer, fix the cause, and rerun. A later gate must not hide an earlier failure. Chapter recap. First, build and staging stop known errors early. Second, shadow and limited traffic make real differences visible while keeping impact bounded. Third, production still needs continuous monitoring and a human who can withdraw permission. Finally, build the 3-layer stability checklist so you have an acceptance sequence you can reuse in any AI workflow. Write the task and pass condition first, input range, correct outcome, time limit, permissions, and the required consecutive passes. Then inspect the tool layer, tool choice, parameters, sequence, error returns, and permissions must all leave a trace. Inspect the reasoning layer next, Key judgments need sources, the logic must stay consistent, and low confidence must trigger a question or pause. Then inspect the output layer. Facts, completeness, format, and business outcome each need an explicit threshold. Write the human takeover rule last. Stop on permission violations, privacy, money, public publishing, irreversible changes, or repeated anomalies. Feed every failure type back into the test suite. The next version must pass both the same failure and new boundary cases consecutively. Screenshot this 3-layer stability checklist and use it to review your workflow. Chapter recap. First, define the consecutive pass count and stop conditions. Second, test tools, reasoning, and outputs separately. One layer cannot cancel another. Third, hand high-risk work to a human and turn failures into regression cases. To sum up, one correct AI agent answer doesn't mean it's reliable. Reliability is not eventually getting a correct answer. It is repeatedly passing tool, reasoning, and output gates under defined conditions. Start with a small test set, then shadow mode and limited traffic. Every failure enters regression, and a human can always withdraw permission. Which AI workflow would you put behind a consecutive pass gate first? Tell me in the comments. Follow Tiny Agent. Tiny Agent helps you get better at using AI.